Alright, so today we're going to have a look at subtopic 3.3 of sketching graphs, and we're going to have a look at some reciprocal functions. So a reciprocal function is a function in the form of x is k over x, or f of x equals k over x. Okay, remember they're the same thing, where k equals not 0, so that top number is not a 0, but it is a constant. Okay, so hopefully you've heard the word reciprocal. We'll have a look at what these mean now. So the simplest example of a reciprocal function is if that k is just equal to number 1. So we get f of x equals 1 divided by x. And here's the graph here. So you can see that for our negatives, in our negative x values, we see we are in the negative y's, and for the positive x values, we're in the positive y. Okay, and you're seeing here that we are splitting this function across x equals 0, so the y-axis. Okay, and you might recognize that if we make x equals 0 in this function, we get 1 divided by 0, which we can't do. So that's why we're getting this asymptote. So that's another word that you hopefully have heard before, asymptote. Yeah. Okay, so that was a reciprocal function. Now, this is slightly different wording, but the reciprocal of a function of f of x, so the function f of x, the reciprocal of that function is 1 over f of x. Okay, and that's what we're going to be using moving forward. Now, this is a bit of a side note, but when we're talking about 1 over f of x, so 1 divided by some function, the function we're going to be talking about is going to be linear, quadratic, or trigonometric. Okay, so you can basically put any function down there in the denominator. We're just going to be talking about the linear ones, the quadratic ones, or the trigonometric ones. Okay, so here are our rules. Now, this looks like there's a lot. So there's a total of 6 there. But basically, they work together. So really, there's only 5. And if you say 1, then the opposite occurs. So what I mean is, so basically, let's start at the top. When we have a function that's a reciprocal function, so when y equals 1 divided by f of x is graphed from y equals f of x. So you can see this was our original, and then we've just put it in the denominator here. The zeros of y equals f of x become the vertical asymptote of 1 over f of x, and the vertical asymptotes become the 0. So we're just going to swap them. So that's when I said we've got 6 rules, but really we only have 3. So if you've got a 0 in a function and you find the reciprocal, that becomes the asymptote. Or if you've got an asymptote, those then become the zeros. So I'll show you what I mean. So we've got our function, this was the one we looked at earlier, f of x equals 1 over x. Now my reciprocal function, let's have a look, f of x equals 1 over x. All right, and if we divide in the denominator, we can just bring that one to the top, so it equals x. Okay, and if we just graph basically y equals x, we're graphing along this diagonal here, approximately. So with these first 2 rules, any zeros of y equals f of x become the vertical asymptote. So you can see here we've got a 0 right through that middle point at 0, 0. And that 0 there has become the vertical asymptote of the other graph. Okay. Now if we look the other way, on the other one, the vertical asymptote of y equals f of x become the 0 of the other one. So if we started with, like we did, 1 over x, we knew that was the vertical asymptote. So, let me just put that back. We knew that was the vertical asymptote. So therefore, if we drew the reciprocal, which we did, we knew it had to go through 0. Okay, so those are the first 2. So the next 2 rules, the local maxima of y equals f of x becomes the minima. All right, so you just switch those 2 around, the maximum becomes the minimum, and the local minimum becomes the maximum. All right, so again, from our graphs, both of ours, you can see they go on to infinity in all directions. So we didn't have a maximum and a minimum, but both of them don't. Okay, if we had a maximum at, I don't know, y equals 2, that came up there, we know the minimum would have to be y equals 2 for the reciprocal function. All right, so last two rules here. So when our f of x is greater than 0, 1 over f of x, so the reciprocal function, is also greater than 0. And when it's less than 0, on our y-axis, it's also less than 0 for our reciprocal function. All right, we also saw that here. So you can see that as soon as it becomes less than 0 for our y equals x, it's also less than 0 for our 1 over x. And same here, our y is in our positive here, it's also in our positive here, so that's a match. And the last one here, and it's also, we can see this again on our graph, we'll have a look in a second, but when our function heads towards 0, our original function, our reciprocal goes to plus or minus infinity. And if our function goes to plus or minus infinity, our reciprocal function goes to 0. So you can see here that on our y, when our original pink function is going towards infinity down here, the reciprocal went to 0. Same here, when we went to infinity, our reciprocal went to 0. Now, opposingly, when we have a look on our y-axis, as we get closer and closer to 0 here, eventually we'll reach 0. And when we do, this point here will have reached infinity, so they swap over. Same down here. So as this is heading to negative infinity, we're heading to 0. As this is heading to negative infinity here, we're heading to negative infinity on our y-axis. So those all match, and hopefully we can see those as we go along. Okay, so let's have a look at an example of this. And what we're going to do is graph on the same set of axes 2x plus 1 and y equals 1 over 2x plus 1. So I've just drawn the straight line y equals 2x plus 1. So we know it's got a gradient of 2 and it goes through the y-axis at positive 1. So that's how I drew that one. Now what we know is from our previous one is as this goes off to infinity down here, we're going to be approaching 0. Okay, so you can see as this gets larger and larger, we're going to be approaching 0. And as this goes to negative infinity, that's the same thing there. Now, as we approach 0 here, we're going to approach infinity. So this here, 0, it's happening at about half. That's going to be, if we draw that in there, that's going to be our vertical asymptote. All right, so we know that we're going to have our graph go down to infinity. Sorry, it's approaching, yep. As we're approaching 0 here, we're heading to infinity. Okay, so it's going to be going down this way. And as we come across here, we're going to be approaching 0. All right, same here. So we know as we approach 0, that's going to be up here. As we approach infinity, that's going to be approaching 0. All right, but how do we know where it goes in the middle? So we know it's going to be like that hyperbola shape that we've seen before with the 1 over x. The other thing we know is these functions are actually going to be the same, and the word we use is invariant. Okay, they're going to be invariant when this thing, the bottom number, equals -1 or 1. All right, so let's just have a look why. So if I go y equals 1 over, this bottom one's going to equal 1 when the x is 0, so 2 times 0 plus 1 equals 1 over 1. Okay, so that's just 1. If I put in 0 to the other equation, so y equals 2 times 0 plus 1, I also get 1. So we end up getting the same thing. So at 0, for our x, these are going to be the same. So they're both going to go through this point here. So the upper part of my hyperbola is going to look like this and cut through there. Now, it also works for -1. So this one's not quite as obvious to see. The way we can work that out is we can just put in 2x plus 1 equals -1 and just solve for that. So if I subtract 1 off both sides to get rid of this, I'm left with 2x equals -2. And now I divide both sides by 2. I get x equals -1. All right. So when x equals -1 when x equals -1. Okay. So those two match. If I put it back in this side, so y equals 2. So this one here times -1 plus 1. I get 2 times -1 is -2 plus 1, which equals -1. So those are the same again. So at the point -1, just here, they're going to be invariant as well. So it has to go through here and they have to both touch there. So those two graphs intercept at x equals -1, because we worked it out, and x equals 0. Okay, so just to make sure you're fully convinced, I've drawn both those lines, 2x plus 1 and 1 over 2x plus 1. You can see they intercept at 0, 1 and -1 and 1. Okay, so that's a technique on how to do that, and you'll have a go at those now. Thank you.